Yeah, good evening students. Based on your request for this video, compensation. Three types of compensation. One is diode compensation, another one is thermistor compensation, third one is transistor compensation. Now we see the thermistor compensation. Normally, thermistor is a device that it's also thermistor is also a thermal resistor. Thermal resistor means the resistance of this thermistor is depend upon the temperature. Okay, the thermistor is a negative temperature coefficient of device. What is negative temperature coefficient? That is two quantities there, one quantity increasing, another one is also increasing, means that is called as positive temperature coefficient. One is increasing, another one is decreasing, means that is the negative temperature coefficient. Okay, now our thermistor is a negative temperature coefficient of device. Now listen, in this thermistor we are using a voltage divider biasing. Because that bias is universally accepted, no, that's why we are using voltage bias. In this R1 and R2 are voltage divider resistor, RC collector resistor, RE emitter resistor. The current flow through the RC is IC, collector current. Then input drop is VBE, output drop is VCE. Here the resistor R2 is replaced by our thermistor RT. That's all. Now operation. Basically the formula IC is equal to beta IB 1 plus beta into ICO. What is this equation means? This is the generalized equation. Normally in ED you studied beta is equal to, that is common emitter current amplification, beta is equal to IB by output by input, IC by IB. Here in this electronic circuits one, extra, the next step we are considering the leakage current. So 1 plus beta into ICO is extra order. Okay, so IC is equal to beta IB, that's in ED. Then 1 plus beta into ICO is added in EC1, that's all. Now from this equation it's clear that once temperature increases, ICO increases, that is leakage current. ICO increases means what happened? IC increases, again this IB increases, ICO increases, now again IC increases. So this is the cumulative process. This produces a breakdown in the transistor, that is called as thermal runaway. That is, thermal runaway means self destruction of unstabilized transistor, that is called as thermal runaway. Now listen. Now temperature increases, normal position there is no problem. Now temperature increases, what happen? Automatically temperature increases means IC value is increases, so more current is flow through the device. Now what happen? The temperature value increases means this is negative temperature coefficient, no, this RT value will be decreases. Now here the temperature increases, so more amount of current, this current is flow through R1, then waiting here. Now what happened? This resistance will be reduced, so the entire current is directly go to the resistance, then automatically it directly go to the ground terminal. So the VCC, current from VCC, temperature normal, it's not a problem. Temperature increases, what happened? Collector current increases, more collector current, more temperature. Now what happened? This will be reduces, so the entire current is go to the negative where? Ground. Now here there is no drop. Are you clear? Because the entire current is go to the ground now, so there is no drop. This drop is utilized by this transistor, so there is no drop. What happened? Automatically the VBE value will be reduces. Once VBE value reduces means input current, base current IB will be reduces. IB will be reduces means IC reduces, because IC is equal to beta IB. Once IC decreases, automatically what happened? ICO decreases. So ICO decreases, temperature decreases. Now IC is kept as constant, that's all. So here the temperature effect, that is the temperature effect, temperature increases means what happened? Definitely it will be affected, no, that effect is eliminated. So this type of compensation is called as thermistor compensation. Very clear? This type of compensation is called as thermistor compensation. Now clear is this? Now here the temperature increases, entire current flow through the resistor. Now what happened? The value of RT decreases. RT decreases means VRT, the drop is decreases, but IRT, so the more current is flown now, so IRT will be increases. Please listen. Temperature increases, ICO increases, which one is decreases? RT decreases. RT decreases means VRT decreases, drop decreases, because the entire current IRT is directly go to the ground, no, IRT will be increases. Once IRT increases, automatically what happen? VB decreases, IB decreases, IC decreases, because IC is equal to beta IB. Now our IC is kept as constant. Are you clear? Okay. Thermistor, thermal resistor. This device, resistor depend upon the temperature. Next one is negative temperature coefficient. What is negative temperature coefficient? Temperature increases, resistance decreases. Okay, so here we are using voltage divider bias is used. Next one is RC. What is RC? Current resistor. RE, emitter resistor. R1 and R2, voltage divider resistor. Here R2. R1, R2. Here R2 is replaced with thermistor RT. So VB is the input drop, VC is the output drop. Thanks for watching. Subscribe our channel. It's useful for you. Put like. Otherwise, just dislike. Then comment box. You tell why you isn't interested to see the video. Right? Why you put a dislike button. Thanks. Thank you.